Hi guys, and welcome to the Properties of Logarithms video. In this video, we're going to go over how to expand and condense logs using the product and quotient rule as well as the power rule. These properties are quintessential for solving exponential equations as well as solving logarithmic equations. And you'll know you're successful when you can expand or condense a log using these properties accurately. So let's get started. Let's start with some basic properties. All of the properties we are going over today work if and only if the bases of the logarithms we are using are the same. So, i.e., log base 2 of 8 plus log base 3 of 8 cannot be simplified because the base of one log is 2 while the base of the other is 3. And then log base 2 of 8 plus log base 2 of 8 can be simplified since both bases are 2. And just remember that if a logarithm is written without an indicated base, we call that a common log, and it is really written with a base of 10. So, i.e., the log of 8 is equal to log base 10 of 8. So the first rule, and for all three of these rules, I'm going to kind of just go through them quickly. So if you need to pause the video to get these properties down, then feel free. For the examples here, for where it's like 4 times 6, it works with any number or variable. I just chose 4 and 6 to illustrate it as nicely as possible with some easy numbers. So if you have a product inside the argument of a log, then you can rewrite it as the same base log of one factor plus the same base log of the other. So the example is the log base 3 of 4 times 6 is equal to the log base 3 of 4 plus the log base 3 of 6. You can use this to either expand or condense logarithms, and here's what it looks like both ways. I did it for log of 4x, and then I took the log 4 plus log x to make log 4x condensing. So expanding is growing it and turning it into multiple logarithms, and condensing it would be taking multiple logarithms and shrinking them down into a single one. The next rule is the quotient rule, and this links division and subtraction. If you noticed earlier, the product rule links addition and multiplication. This one links division and subtraction. If you have a fraction in the argument of a log, then the fraction can be rewritten as the log of the numerator minus the log of the denominator. So the example here is the log base 3 of 1/2 is really equal to the log base 3 of 1 minus the log base 3 of 2. You can also use this to either expand or condense logarithms, and here's what it looks like both ways. So I expanded the log of 4/3 into the log 4 minus the log 3, and I condensed log 4 minus log 3 into log of 4/3. And the final rule is the power rule. This rule is what we use to solve exponential equations. So how do we figure out what the law, like if I had something like 4 to the x power equals 12, how do I solve for x? Well, we use the power rule in that situation. If a logarithm's argument is raised to an exponent, then the logarithm can be rewritten as the exponent times the log of the number. So the log base 3 of 4 squared, 4 squared being the argument because it's what's inside the parentheses, that's equal to 2 times the log base 3 of 4. So you can see that I used it in both ways. Expansion, in the expansion version of this would be you would write a coefficient times a logarithm, and then condensing would be to take the coefficient and put it back inside the argument. So let's do some examples. Expand each logarithm. Okay, so expanding logarithms is all about breaking them down into multiple logs. So when you have an exponent inside the parentheses like this and it belongs to a single variable or a single number, you're going to split them and then you're going to do the power rule. If the exponent is on the outside, then you're going to do the power rule first. So what we're going to do is this is going to be the log base 6, and I'm really lazy, and I'm going to copy the log base 6 3 times because I don't want to write it 3 times. So log base 6, and it is multiplication inside the parentheses. So the multiplication means we're going to be using the product rule, and the product rule is going to be addition. And then I've got 3 different arguments to add here. So the first is going to be the log base 6 of A plus the log base 6 of B plus the log base 6 of C to the 6th power. So now I'm not quite done. This are considered simplified and expanded, but this one, because of the variable raised to an exponent, that needs to be simplified using the power rule. So what I am going to do is I'm going to try to copy these. Yeah, that'll work. And instead of c to the 6th power, what we are going to do is use the power rule to kick that 6 out front. So it's going to be 6 times log base 6 of c. And then these are all considered expanded and simplified. So let's take a look at another one. We have log, and it's a common log because it has no base, of u to the third times v to the third. So what we do here is we are going to, because the exponents are inside the parentheses, we're going to do the product rule first, and then we're going to use the power rule. So it's going to be the log of u to the third plus the log of v to the third. And now we do the power rule. The 3 is going to come out in front, and the 3 is going to come out in front. So we get 3 times log of u plus 3 times the log of v. And that would be considered expanded and simplified. Okay, so now I'm going to ratchet it up a notch for these next ones. Expanding in difficulty, I mean. Expand each logarithm. So I've got w, and even though it's not shown, it's w times the square root of u times v. So u times v in the square root symbol. Another way to express this mathematically would be u times v in parentheses raised to the 1/2 power. The square rooting of something is to the 1/2 power. So what we are going to do is we are going to rewrite this log expression with exponents instead of square roots. So log base 2 of w times, and I need a second set of parentheses here, u times v to the 1/2 power, close the parentheses. So we're going to use the product rule first to break this apart. So we're going to get the log base 2 of w and then plus the log base 2 of u times v to the 1/2 power. So this is an example where the exponent is on the outside. So what we are going to do is we're going to use the power rule to kick it down first before we break it apart using the product rule. You could technically break it apart using the product rule, but it becomes, I think, more difficult. So the front is not going to change. So the front of our expression is not going to change. And so I'm just going to copy paste that and make a couple changes here. So it's going to be u times v here, and we're going to kick the 1/2 out front. So it would be 1/2 half times log base 2 of u times v. And then now we're going to break this apart using the product rule again. So log base 2 of w plus. So when you break apart a log that has a coefficient, the coefficient gets applied to both of the products. So it will be 1/2 times the log base 2 of u plus, and then this is what I'm talking about here, 1/2 the log base 2 of v. So this would be considered fully expanded and broken apart. So when you have a parentheses like that, and it's like a power of the entire parentheses, when you split it and you use the power rule, and you split it again with the product rule, you apply the coefficients to both parts of the product rule. Okay, so number 4 is multiple things going on. So we have a quotient. In the quotient, we have a product in the denominator, and then we also have this raised to a power of 5. So because the power of 5 is on the outside of the parentheses, we're going to deal with that first. So we're going to kick it to the outside to make it 5 times the log base 4 of x over z times y cubed. The next thing we're going to do is we are then going to break apart the quotients here. So we're going to get 5 times the log base 4 of x, and because we're breaking apart a quotient that has a coefficient in front, we have to apply it to both. So 5 times the log base 4 of z times y cubed. Okay, so I'm going to need a bunch of space for this next line. After I have dealt with the quotient, now I need to deal with the product that's inside the second half only. So I'm going to have 5 times the log base 4 of x minus 5 times the log base 4 of z. And then the plus the 5 times the log base 4 of y cubed. That didn't work so well. Try it again. Y cubed. Okay, so then the last thing we have to do is get that cubed off the y. So we're going to multiply the front coefficient that already exists. And because most of this is the same, I'm just going to copy paste it. But instead of y cubed over here, the cubed is gone, and we're going to multiply. So we're doing this then next. So 3 times 5 is 15. And then it will leave y all by itself. So the final answer is 5 times log base 4 of x minus 5 times log base 4 of z plus 15 times log base 4 of y. Okay, so that was a pretty tough last one, but nothing we can't handle. So let's move on to condensing. And if you look at the first problem, we actually have natural logs. So all of these properties work for natural logs as well. So it's not a big deal. All we're going to do is, since we both have natural log, we know they're the same base. And so we see that there is a minus sign between them. So to condense them, we're going to need to create a product. But a quotient. But because we have coefficients out front, the first thing that we need to do is kick the coefficients back up to being exponents. So when you're condensing, you take all of the coefficients and make them exponents again. So it'll be the natural log of a squared minus the natural log of b to the 12th. So that was kicking this up and kicking this up here. And then the next thing we're going to do is deal with that minus sign, which means we're going to create a quotient. It is going to be the natural log of, and here's where we create our quotient, a squared over b to the 12th power. And that is our condensed expression. For number 2, it's very similar, except now we're back to using logs instead of natural logs. So what we're going to do is first kick the 20 and kick the 4 up. So the 20 is getting kicked up here, and the 4 is getting kicked up over here. So it'll be log base 6 of x to the 20th power plus log base 6 of y to the 4th power. And I forgot my parentheses here for my arguments. And then I can use the product rule with the plus sign to condense them into a single log base 6 of x to the 20th power y times y to the 4th, which you don't need to write a multiplication sign between the two variables. That's okay. Close the parentheses, and this would be our condensed expression. So we're going to move on to condense each logarithm. Another page of condensing logarithms. In this one, we have number 3. We have logs of base 2, base 2, base 2, and these logs here are divided by 2. That is the same as, I'm going to rewrite it really quick. So it would be log base 2 of 5 plus, that would be saying 1/2 times the log base 2 of 6 plus 1/2 times the log base 2 of 7. So dividing by 2 like that is the same as writing times 1/2. So the first thing we're going to do here is kick these 1/2s up to be exponents using the power rule. So I get the log base 2 of 5 plus, now log base 2 of 6 to the 1/2 power plus log base 2 of 7, put my little dash to the 7, to the 1/2 power. Now, when you raise something like x to the 1/2 power is actually saying the square root of x. So what we have is, and it's going to take an additional line of rewriting, but I think that it's worth it for clarity's sake, the log base 2 of 5 plus the log base 2 of the square root of 6 plus the log base 2 of the square root of 7. And so now I can go ahead and create products for all of these. Or excuse me, I can make one big product using the product rule because I have addition signs. So it will be one long product of log base 2. And in the parentheses, it will be 5 times the square root of 6 times the square root of 7. And just for some more clarity's sake, you're totally fine to leave it like this. I prefer myself to write log base 2 of, and then in parentheses here it would be 5 times the square root of 42. I consider the final bottom one to be fully condensed. However, if you did square root of 6 times square root of 7 and didn't multiply those out, that would be totally acceptable as well. So that one condensed. So let's take a look at the next one. So I have 2 log 9 of x plus 6 log base 9 of y plus log base 9 of z. So I'm going to kick the 2 up first. So it'll be log base 9 of x squared plus, and then I'm going to kick the 6 up, log base 9 of y to the 6th power plus log base 9 of z. So I'm going to go ahead and then use the product rule to write them as one single product. So it will be log base 9 of, and then I'm going to have x squared times y to the 6 times z. And that would be a finished, completed simplification, and we condensed our logarithm fully. So that's it, guys. In this video, we went through the 3 properties of logarithms and how they apply to logs of the same base. We completed 4 examples of expanding, and we also completed 4 examples of condensing. So thanks for watching, guys. That's it, and I will see you in the next video.